Okay, so what I wanted to show you here is an electroscope, which we talk a little bit about in lecture, but it's kind of nice to see the real thing, which we do normally have in the labs. There are different types of electroscopes. The common one, which is kind of the classic design, is a kind of gold leaf or aluminum leaf or whatever leaf design, where you'd have some sort of top piece which is connected, it's made of metal, and it's connected down to an apparatus with two leaves, which are very lightweight pieces of metal that if they get charged, they'll repel from one another. And the idea there is that the more they repel, the more charge they have, whether it's through induction or just adding charge. This is a slightly different design, but it's easier in many ways to see the charge impact. The downside of the leaves is that they're usually very small. So let's take a look at how this one works. Okay, so very similarly, there's this little top where you can add or induce charge. And then what happens is it is connected, because it's all metal, through and into this, which is also metal, and then also into this, which can freely pivot. So you've got this needle that can pivot. Now, if it's got no charge, then it's going to be completely vertical. And so that's going to be at 0 point. And the more that it moves, the more that there is a repulsion between the needle and the support beam here. And this whole thing is on plastic, and that keeps it insulated from the ground, so that when we add charge, the charge will stay just on the metal parts. Okay, so what does this do for us? Well, it gives us an ability to look at things that we've been talking about, where you can have a variety of different materials. There's a few different examples. Glass is the classic one. It's just a rod of glass, and we can look at plastic as well. And then you can use different fabrics. And we talked a little bit about that in lecture. So you can take some sort of, look, the classic one was glass and silk. And so the idea there was, through friction, you can leave a charge on the rod. And so if there's enough friction here on the rod, it should accumulate an electric charge, and we should be able to measure it with the electroscope. And now we're going to get pretty close and see if we see any movement. And it's actually pretty difficult. So we could do it a whole lot and try to build up a charge on it over and over and over. But interestingly, there's actually while this will work, especially with higher grade electroscopes, there's actually a way to get a whole lot more charge a lot quicker. And so while this theoretically does work with a variety of materials and fabrics, and you could try these, I'm going to jump right to the kind of big option, which is a balloon. This tends to work very well if you're willing to rub it into your hair. For science, I don't mind. So we will collect some charge, and then we will see whether we can measure it with our electroscope. Okay, I probably look ridiculous. So let's bring the balloon close to the electroscope, but I'm going to try not to touch it. And I'm going to try not to get so close that the charge is actually going to physically jump across the air, which will happen within, I don't know, half a centimeter. You can see that we can get pretty clear movement of the needle, and that's all induced. So what's happening is there's a charge on the balloon, and that's going to be either attracting or repelling the electrons, which can freely move around the metal. And so we end up with a net charge down here, and that's going to be repelling. So we're going to have it could be a negative here and a negative along there, and they're going to repel. That's quite a substantial charge. And we can see if it's induced by kind of walking away. And it looks like, despite the fact that I kept a distance, some of it actually jumped over. So we could just ground this and get rid of the charge. So I'm just going to touch it, and then the net charge should just move into me and be grounded. Okay, so now it's grounded. We should have no net charge. And I can bring the balloon back. Probably lost a little bit of its charge. Take it away. Okay, so there it didn't jump at all. It's going to collect a little bit more, and what we're going to do now is just add it right. I'm going to have contact. And hopefully you actually heard that. I heard it. Hear a little snap. Tiny wee bolt of lightning. Whew. That was a good snap. Okay, so now we've got quite a lot of charge that's now physically on our scope. And we can see that the angle here is fairly substantial, especially compared to what we were getting with the glass rod. And so we get this kind of semi-quantitative measurement of how large that charge is. We could deposit just a wee little bit of charge with the glass rod. We could deposit a whole lot of charge off of the rubber balloon. And so then we can ground it. And there we go. So that's our just basic introduction to electroscopes.